Hi everyone and welcome to our assignment videos. But first, let me introduce to our member teams. First, we have Muhammad Badrul Amin bin ZAWAWI. Second, we have Muhammad ARIF AFIFI bin HASBULLAH. And next, we have MT Afiq bin YUSAINI. And last, Muhammad HASIF bin AMELUDIN. Let me give you an introduction of our assignment. What is a divergent theorem? A divergent theorem, also known as the Gauss theorem, used for evaluate surface integral directly, can be tedious, particularly when we have the outward unit normal changing at each point on the surface. So we need to break the surface into several subsurfaces according to their orientation. Gauss theorem establishes a relationship between a surface integral over the boundary of a solid and a triple integral over the solid. It is in fact a generalization of the normal form of Green's theorem in 3 space. If fxyz equal to fxyzi plus gxyzj plus hxyzk, then we define the divergence of f written div f, or sometimes written as upside down triangle, then f.
Gauss' law states that the total electric flux passing through a closed surface is equal to an enclosed charge by the surface divided by EO. We can see the equation here that the integrate E multiplied by dA equal to Q enclosed divided by EO, where the Q is total charge within the given surface and the EO is electric constant. Here is the question Gauss' law. By using Gauss' law, find the electric field inside the cylinder given below. Given that the surface S equal to 4 meters cubed and the length equal to 2 meters. First, we have to find the Q enclosed. Here is the equation of general equation of the Q enclosed, where the K is constant and the S is variable that we can change that respect to S. Firstly, we inside the value that we have in the equation, and the K we move to outside because it's constant, and the S we integrate with respect to S. After that we just inside the value to the S to get the first value of integrate of respect to S. Second, we integrate with respect to theta, and we inside the value into the theta. After that, we get the value of integrate respect to theta, and then we integrate back with respect to z, and we inside the value we get inside the z, and then we get the value of the integrate of or integration of the respect to z, and we get the q enclosed that the value is 4096 divided by 3 pi k. Here is the second that have in the equation that a is the 2 pi length surface. Then electrofield constant that k is 8.99 multiplied by 10 power of 9. The EO is 8.854 multiplied by 10 power of negative 12. We have the equation that we can get the electric field that E multiplied by 2 pi length surface equal to 1 over EO multiplied by 4096 divided by 3 pi k. We want the E, that we have to move the 2 pi length surface to the another side. Then we get the E equal to 4096 pi k divided by 3 multiplied by 2 pi length surface multiplied by EO. Then we inside the real value in the equation, and we get the last answer that electric field is equal to 2.166 multiplied by 10 power of 22 volt meter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So I would like to explain how to solve this question. The question is, use the divergence theorem to calculate the surface integral where fxyz equal to x 4x cubed I plus 6xy squared j plus 9y squared zk, and S is the surface of the solid bounded by the parabola z equal to 16 minus x squared minus y squared and the xy plane. To solve this question, the first thing we need to do is sketch the solid using all the equation given in the question. The reason why we sketch the solid is because it is easy for us to find all the boundary of the integration. So after sketch the solid, which is look like half of sphere, we get the boundary of z equal to 0 until 16 minus r squared, r equal to 0 until 4, and theta equal to 0 until 2 pi. So the next step is find the divergent f, which is equal to partial derivative against x for 4x cubed plus partial derivative against y for 6xz squared plus with partial derivative against z equal to 12y squared z. The next step is we put all the boundary and divergence f that we get into the equation. So we get 0 to 2 pi, 0 to 4, 0 to 8 minus r squared, 12r cubed dz dr d theta. We integrate z, we get 0 to 2 pi, 0 to 4, 12r cubed z dr d theta. So substitute the value 16r squared into and 0 into the equation, and we get 0 to 2 pi, 0 to 4, 192r cubed minus 12r to the power of 5 dr d theta. After that, we integrate r, we get 0 to 2 pi, 48r to the power of 4 minus 2r to the power of 6 d theta. Substitute 4 and 0 into the equation, we get 0 to 2 pi, 4096 d theta. And integrate theta, we get 4069 theta, and substitute the boundary of theta, which is 2 pi and 0 into the equation, and lastly we get the answer is 8192 pi.
Hey guys, my name is MTAFIQ and this is our first example of Gauss law. So, from the equation, we can get fxyz is equal to 4xi plus 8yj plus 4 cubed zk, and x2 plus y2 equal to 16, and z equal to 0 and z equal to 4. So from this, we can get the estimated graph, and after doing so, we can get the full equation with the first lower and upper limit is 0 till 2 pi, 0 till 4, and lastly is the same 0 till 4. So after we do the standard integration, we will get our final answer is 4,864 pi. We can use 3D graph Desmos or 3D GeoGebra to create the 3D graph of our example. But for this example, we're gonna use GeoGebra. By putting all of our information from the example, we can get the 3D graph of our question, and as a result, we can say that the 3D graph is kind of example of our estimated graph of our solution. Thank you.